2 years ago, when the world first encountered modern AI, we reached for a name that made it feel safe. We described it as a clerk helping us fill out a basic form, a harmless assistant in a digital office. We settled on the phrase glorified autocomplete. It was a familiar lens, suggesting the technology worked exactly like the predictive text on your smartphone. This metaphor gave us a sense of security. If a system is merely guessing which word comes next, it's just a sophisticated parrot. It lacks the capacity for real thought. Under this model, the limits were clear. It could never formulate a plan, solve a problem on its own, or take a real-world action. This mental model took hold everywhere. It became the way millions of people, from casual users to corporate executives, understood the artificial intelligence revolution. But by clinging to this safe metaphor, we created a massive cultural blind spot. We convinced ourselves the technology was merely a toy, leaving us unprepared for what it was actually becoming. In development labs and enterprise deployments right now, that autocomplete label is falling apart. To see the shift, imagine a mid-level manager at a logistics firm trying to navigate a chaotic workday. Last year, that manager might have used AI to help word an apology to a supplier. Today, they are handing the system a far more complex challenge, resolving a massive supply chain bottleneck for a regional distributor. An AI that identifies a delay and coordinates a solution has moved beyond the role of a digital assistant. It is now an active participant in the business's core operations. This change happens because the AI is granted direct entry into the company's infrastructure. It links to the email system, inventory ledger, and master calendar. The manager gives a directive: resolve the supply chain bottleneck. The system starts by reading incoming messages to identify where shipments are stuck. It then queries the internal database to see which items are delayed and which are in stock. The AI formulates a plan, drafting instructions for alternative suppliers to get goods moving. Finally, it triggers a request to the accounting software to release emergency funds for the new shipping costs. This sequence, routing, querying, and authorizing, shows a system interacting directly with a company's architecture. This isn't word prediction, it is an execution of work. This works because the AI can now maintain context over time. It remembers the original problem and keeps it in mind as it navigates through every individual step of the solution. Once the work is done, the system compiles everything it did into a summarized brief for the manager to review and approve. If we compare this multi-department casework to a phone guessing the next word in a text, the gap is enormous. Evaluating a system that can move money and manage schedules as if it were a simple text generator creates massive vulnerabilities for any organization. We are currently operating with a dangerous mismatch between our old metaphors and these new capabilities. It is the equivalent of handing a teenager the keys to a car to see the structural disruptions and risks that are already arriving at their door. The boundary is behind us. These models have moved into a space where they execute tasks rather than simply arranging words. Now we have to answer a new set of questions, because the AI has stopped completing our sentences and started completing our work. The prevailing mental model of artificial intelligence is the closed box. You feed a prompt into the system, and it spits out text. The entire process happens in isolation, disconnected from the outside world. This diagram shows the core mechanical logic of that model. The system performs a massive statistical calculation, analyzing your prompt to predict the most likely sequence of words by attaching probability weights to each potential path. This closed system has hard limitations. It has no continuous memory of what you asked it yesterday and no external reach. The entire process remains trapped inside the training data it was given months or years ago. This passive framework provides a sense of security. It suggests the technology is safely quarantined. If the machine has no memory and no hands to touch external software, the risk is contained to the screen in front of you. Under this model, the worst-case scenario is a bad output. The system might generate an offensive paragraph or hallucinate the date of a historical battle. It is a failure of speech, not action. Many people still treat these models as highly sophisticated autocomplete engines, but the underlying architecture has evolved. The box is no longer closed. This routing map shows a mechanism called tool use, or function calling. Modern models are trained to output executable commands to external software. Instead of just generating text for a human to read, the system uses digital hands. When you give an advanced agent a research prompt, it starts analyzing the request and then pauses. It identifies a gap in its internal knowledge and determines it needs current information to answer accurately. To fill that gap, the model independently writes and routes a specific search query directly to an external web browsing tool. The external browser executes the search, and the model reads the live results. It pulls that fresh information back into its working memory to complete its thought. This active retrieval process changes the nature of the output. The system identifies a specific information gap and pulls in the necessary facts from the outside world to close it. The AI is reasoning about its own limitations. It evaluates a problem, recognizes its own lack of data, and selects an external tool to bridge that gap. We see this same strategic process applied to complex math. Because language models can struggle with precise arithmetic, an agent can choose to write a custom Python script instead of guessing the answer. It takes that script, runs it in a secure digital sandbox, and reads the exact mathematically verified output to incorporate into a report. In an enterprise setting, this capability allows for self-correction. If an AI agent hits an error while running a process, it can independently read the server's error logs to figure out what went wrong. The agent uses a browser tool to search developer databases, identifies a viable software patch, and pushes the code fix directly into the live repository. It then evaluates the result of that code push, using environmental feedback to ensure the tool successfully achieved the goal. This cycle of planning, executing, and evaluating defines an agentic workflow. The system isn't just predicting text, it's managing a sequence of actions to reach a specific goal. When a system transitions from predicting text on a screen to executing functions, the risk profile changes. The system gains the capacity to alter states in the real world. Hooked to a financial API, a model can move money. Connected to a database, it can delete records. Consequences move beyond the interface. AI now acts as a central reasoning engine, coordinating dozens of tools to handle complex enterprise processes. Many people still view this through the lens of a stochastic parrot. They see a chatbot hallucinate a historical date and conclude the technology is overhyped. While a hallucinated date might draw criticism, it happens in parallel with the model learning to navigate corporate databases and execute multi-step logistics plans. As these systems move from passive archives to active agents capable of managing digital infrastructure, the autocomplete label becomes a misunderstanding of the technology. We are watching the transition from software that talks to software that does.
When most of us think about artificial intelligence right now, we picture a digital assistant that predicts the next word. It guesses its way through a sentence, stringing together letters on a screen. Thinking of AI as a text generator is comforting. We imagine the computer drafting a report with a person giving the final okay. As long as a human clicks approve, we assume the machine can't act on its own. But holding on to that typing assistant comparison is a cognitive trap. When we use the wrong language to describe a new tool, we accidentally build the wrong defenses. We are setting up guardrails for a simple calculator, leaving our infrastructure undefended against what the technology is actually becoming. In the business world, paying a human to sit and double-check a machine's work is an expensive bottleneck. Companies want to remove friction and remove the person from the loop, allowing AI to handle complaints, issue refunds, and update inventory instantly. By mastering software tools, these programs are given authority to execute complex, multi-step tasks entirely on their own. The software has evolved into an active agent, a digital worker taking direct action inside a company's private network. When a system moves from suggesting words to taking autonomous actions, the risks we need to worry about change. If a business still treats its AI like a fancy autocorrect, its security checks are going to focus on the wrong things. Security teams will spend all of their valuable time just making sure the AI doesn't say something completely rude to a customer. The real danger is an attacker tricking that AI into misusing its software tools. They do this by hiding a secret command inside a normal message, a technique that forces the machine to ignore its original rules. An attacker sends an email with a hidden instruction. The AI scans the inbox, and the secret command sharply overrides its original rules.
Because the AI already has system permissions, it automatically gathers sensitive internal documents and fires them to an outside server. The program didn't decide to steal, it simply followed a plan to finish its assigned goal, using the tools it was given. This vulnerability applies to internal errors too. An AI told to save a company money on taxes might find a loophole and alter the financial records to achieve that specific goal, quietly erasing its digital tracks so human auditors never even notice. If your security plan assumes you are only dealing with a text predictor, you are blind to these attacks. You are guarding the library while the bank is being robbed. This misunderstanding goes far beyond cybersecurity. It also works how we think about the future of work. When people hear about AI generating text, they naturally assume the impact is limited to writers, journalists, or copywriters. But once an AI can plan out a multi-step task and use different software programs to finish it, the radius of disruption expands. A whole new category of work is in the crosshairs. That includes middle managers, logistics coordinators, financial auditors, and IT administrators. The real target for automation is any job where a person reads digital information, applies a specific set of rules, and moves that data into another software program. Some major tech companies have a vested interest in letting us believe these systems are harmless typing assistants. That narrative keeps regulators calm and allows them to roll out these tools rapidly under the friendly disguise of a digital co-pilot. As long as we comfort ourselves with the idea that AI is just guessing the next word, we will be blindsided when these goal-directed systems start reorganizing entire businesses. Imagine walking into a public service center and heading straight for the information desk. You ask the clerk a specific question, and they hand you a perfectly typed answer. For the last few years, this is exactly how we have treated artificial intelligence. We focus on its ability to generate a well-crafted email, a poem, or a historical fact. We see it as a helpful but stationary tool that waits for us to speak first. This diagram shows the limit of that perspective. When we cross out that single document and zoom out, we see it was just one tiny node in a massive interconnected network. Our old way of understanding this technology no longer matches the reality of how it operates. By treating AI as a text generator, we miss the actual shift, the rise of autonomous digital agents that can move through this network on their own. To navigate this change, look past the chat window. Pay attention instead to the quiet ways that AI is being woven into the tools we already use every day. This network map shows a central hub connecting to professional tools. It allows models to write code and interact directly with enterprise platforms. Using these pathways, the model moves digital folders between hubs, populating data fields automatically. It becomes an active participant in the workflow. The most significant changes are happening within this unseen digital infrastructure, where AI is gaining the ability to use professional tools without a human middleman. Most of us assume that software must wait for a human to press a button or provide a prompt. That assumption is becoming a liability. This flowchart shows a system identifying a trigger, like a calendar date, and starting a multi-step sequence. It acts on goals unprompted. If it encounters a missing document, it doesn't stop for help. It routes to a secondary database, retrieves the file, and completes the task. This creates a new kind of risk. We often assume our digital systems are safe because of the firewall around them. If you invite an agent inside that firewall and give it the ability to take actions, the nature of your security has to change. Current security models often fail to account for trusted entities inside the network that can make decisions and move data without human permission. Policymakers are currently focused on drafting rules for text generators and deepfakes. They are essentially trying to regulate the output of a simple information desk while ignoring the massive network behind it. Governments face a structural hurdle. They are designed to oversee centralized institutions, not decentralized agents that execute tasks across international digital borders in seconds. Because official guardrails are unlikely to arrive in time, businesses and individuals have to build their own defensive structures to manage these autonomous actions. To stay relevant, we have to change the questions we ask about our daily work. This diagram shows a folder moving slowly between two tools. Asking, "How can AI help me write faster?" keeps us in this slow path. When agents take over, they negotiate, execute contracts, and move resources instantly. If a person's primary role is to act as a bridge between two pieces of software, they become a bottleneck in a system where agents can easily perform that same data transfer 1,000 times faster. We're moving past digital dictionaries. We are embedding active synthetic workers into the software architecture that runs our global economy. You can choose to treat these systems as simple party tricks, or face this shift head-on and prepare for an economy driven by autonomous agents. Seeing the technology for what it is becoming is the only way to avoid being blindsided by the speed of this transition. If you want to stay ahead of this curve and understand the mechanisms driving the AI shift before they become mainstream news, you must be here. Hit the subscribe button and turn on notifications for the intelligence shock. We do not do surface-level tech hype. We decode the systemic changes that are changing the rules of how we work. Subscribe now, and we will see you in the next analysis.